Hello all and welcome back to another fine day of mathematical learning. Today, again, not in the textbook. We're looking for surface area of cylinders. Now, we're not trying to fill up the barrel. We're trying to figure out how much paint would we need to paint the exterior of that barrel, or in like manner, how many squares of wrapping paper would it take to wrap up and give away this glass? So surface area is our focus for today. I'm going to ask you to pause. Come on back when you're ready. Now, this was indeed a challenging assignment. Please make sure you bring questions to Monday before Tuesday's end of chapter review, before Thursday's test. Surface area, whoops, never finished this. We've done pyramids already. We've done prisms already. Today is a surface area of a cylinder. Onward we go, where I'm going to actually pause and talk about how to find and where there's a formula for finding the surface area of cylinders. I'm going to talk about how to get there. All right, so I'm hoping you see this little blue cylinder on your screen. You notice it is a cylinder with a radius listed and a height labeled as well. Now imagine if this were a pop can and you want to figure out how much aluminum it's going to take to cover that pop can, or any cylinder really. Cut it up, peel it apart, make a net. Are you ready? Here we go. Huh. That's interesting. Let me do that again. I want you to watch as you cut up, just make a slice right along the edge and then peel it apart. What two-dimensional shapes do you see? And I have a hunch that you're already noticing. We got a circle base on the top, circle base on the bottom, and then very interesting, this curved lateral face. It is curved, but this curved lateral face can be flattened into a rectangle. Okay, well, we know, Mr. Callan, how to find two circles. So let's see, we got, oh, it's not going to let me write on here. Bummer. What about up here? Nope. What about over here? Nope. That's okay. Circle plus rectangle. We know how to find the area of the circles. We know the rectangle appears to have a height as one of its dimensions. What is the other dimension? That, ladies and gents, is the key question for today. Now, I'm going to unroll it again, and the question you're asking is, how would we find this last dimension of the rectangle? Hint, pay attention to the yellow arrow. Oh, you see that? See what happened to that yellow arrow? I'm going to do it one more time. As we slowly unroll and unravel, it sure appears that that yellow travels all the way around the circle. Ladies and gents, that is the circumference. 2 pi radius is the length of that rectangle, and the height is its width. So the area of this lateral face, to find that area, is 2 times pi times radius times height. And of course, we have 2 pi times radius squared circles. And that, my friends, is where the formula for a surface area of a cylinder comes from. If you want, mathopenref.com/cylinderarea.html, you're welcome to check that out. I just wanted to point out where this funky formula comes from. But before we get there, let's dig in a little more into nets, shall we? So I wish I could have you guys in class with a hands-on little activity. We actually had this where you could cut it out. You could say, okay, circular base, pi times radius squared. What's the radius of this guy? I made it so that it was 1, 2, precisely 3 units for the radius. 3 squared is 9. And so if this is 9 pi square units, then so would this be. All right. Now, How would we find the lateral surface area? Well, you multiply length times width. And as we already saw, the width appears to be the height of this cylinder. I'm sorry, you can't see it because we're not doing it in class, but we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But now what do we know about the length? Because this length ended up being the circumference of this circle all the way around, we're going to multiply 2 times pi times the radius, and we already mentioned that the radius of that circle was 3 units. 2 times pi times 3 is 6 pi. So if we're going to multiply the length and the width of this rectangle, I guess you could say the circumference times the height. 2 times pi times radius times height. 2 times pi times 3 is 6. 6 times 10 would be 60 pi. So now, ladies and gents, we would add up 60 pi with 9 pi and another 9 pi to get a final area of exactly 78 pi square units. And of course, since we like to list our answers both exact and approximate forms, you can multiply 78 times pi. Use your pi button. Do not please estimate with 3 and 1400ths. 78 multiplied by pi is approximately 245 and 400ths. And again, just to remind you, if somebody said, hey, which amount of money would you like? You'd say, dude, those are pretty much the same. I mean, sure, the pi answer is exact and therefore a better answer, but they're pretty much the same thing, huh? All right, so sorry we can't do that hands-on activity. We're going to focus on nets at the beginning. And so if I cut this cylinder up, I would see a rather large rectangle and then 2 circles, 1 circle on the top, 1 circle on the bottom. I'm going to go ahead and copy the dimensions. And it appears that the height of this is going to be 10 centimeters tall. Therefore, in order to find the area of this circle, pi radius squared, where the radius appears to be 4. If this guy is 16 pi square units, then its congruent circle is also 16 pi square units. But now we're going to need to figure out, okay, how do we find the other dimension of the rectangle? Well, if we recall, if you were to split this up, it would be the circumference of that circle, which is 2 times pi times 4, which is 8 pi. So if we multiply 8 pi times a height of 10, we'd get 80 pi units. Now let's go ahead and add everything up. 16 pi, another 16 pi, and of course an 80 pi gives us a surface area of precisely 112 times pi square centimeters. And if you want to go to the nearest hundredths place, naturally 100 times 3 is about 300. It's going to be a little larger. In this case, it's going to be 351 and 86 square centimeters. Now, just to emphasize, I'm about to show you the formula, but you're going to get the same answer. I just really want you to understand where that formula comes from. Look at what we have here. We have, I'll do this in green so you can try to see that connection. 2 times pi times the radius of the circle, which is 4, times the height of the circle, which is 10. Well, look at there. 2 times 4 is 8, times 10 is 80, times pi. That is precisely what we've already measured. Meanwhile, we have not 1 but 2 circles, each with the area of pi times its radius of 4 squared. I'm going to get rid of this, make it small. So naturally, 4 times 4, 16, double that, 32 pi units. But of course, if we want to find the total surface area, we would add those together. Hey, this looks kind of familiar now, doesn't it? 112 times pi square centimeters. So I don't mind showing you a formula, ladies and gents, but formula does not denote understanding. I want you to really understand, okay, we got the circumference times the height gives us the lateral surface area in green, and 2 times pi radius squared gives us the 2 circular bases. Let's do one more, please. Pause if you want, rewind if you need. Let's do one more, and then we'll get into homework. So, yes, we could pull out our formula, but let's make sure we understand where that formula comes from first with a lovely gonna have a good old net right here. All right, looks to be a measurement of 5 along each and every circle, and then that seems to be a height of 2. So let's go ahead and write that 2 in. Now, to find each particular area of the circle, we would find pi times the square of the radius. In this case, the radius appears to be 5. Don't cut 5 in half. Don't double it. 5 starts at the center of the circle, goes to the outside, therefore it is the radius. 5 squared is 25 times pi gives us an exact area of 25 pi units. And down here, I will write 25 pi units. Now let's go ahead and find, okay, this rectangle, we have 2 by, what's that other dimension? Naturally, it would be the circumference if you cut that up and peeled it apart. So we need the circumference of this guy. Circumference is 2 times pi times the radius. And the radius of that circle is 5. So let's go ahead and multiply 10 pi times a height of 2 to get an area of 20 pi units. Now to find the total surface area, we're going to add up 20 pi units along with 25 pi, and you know what? Another 25 pi. And therefore, the exact area will be 70 times pi square centimeters. If you went ahead and calculated that out, about 291 and 91 hundredths square centimeters. Means whiles, if you must, you may use the formula. Understand, if you watch the colors, understand where this comes from. The circumference of that circle multiplied by the height will give you 2 times 5 is 10, times 2 is 20, 20 pi. Gee, that sounds kind of familiar. And we have not one, but 2 circles, each with a radius of 5. 5 squared is 25 times 2 is 50 pi. Naturally, to find the total surface area, you will add those together. You will get your 70 pi. You will get your approximate answer as well. But let's go deeper and not just know a formula, but know where it comes from. That's what I got, ladies and gentlemen, for you today. Feel free to rewatch the video fast, slow. I'll even give you scrambled answers. That's right, ladies and gents. Here are your scrambled answers. Call it 4C, call it 4D, call it whatever you want. Let's take care of surface area of cylinders using nets and a formula. That's what I got, folks. Take care, do well, and let's grow.